Hello friends, this is Ranet. So today I'll be showing you the 8th experiment of the Unix lab. So there are two experiments to start with. I'll show you the first experiment of the 8th one, which is named by the following. So this is the code which I have over here. So I'm including unistd.h and the system types.h for creating these pipes. So what I'm basically doing over here is I'm creating pipes and I'll create the parent process and the child process for that. So I'm creating the syntax over here, then I'm entering the seconds. The second is entered over here. Then I'm creating a fork. Now fork is the process which fork is the system call in Unix which creates a new process. So I'm initiating a fork system call and I'm assigning it to PID. So process ID stores a new system call. So if process ID is 0, then it's a child process, and I'm getting the child ID over here, the process ID from here. And if it's in minutes, then I'll give minutes by 60. If it's in hour by 6 minute by 60, and I'll count the number of minutes and hour at the end. Else, if it's a condition where if the process ID is greater than 0, then I'm sleeping for 10 seconds and waiting for the parent process. And the process ID I'll get over here. So to make it short, I'll just simply change the sleeping time 10 by 5. So next I'll execute the program. So I'll enter the seconds over here. So I'll enter around 120 seconds. So I have to wait for 5 seconds. Now, as you can see, 120 seconds give me a child process with ID this. So since this ID is greater than 0, so I have to wait for 5 seconds, and 120 seconds give me 2 minutes 70 hours, and so I get the parent process with the parent ID being this. So this was the first experiment of the 8th. So next I'll execute the second experiment, second subpart, I'm sorry. So this is the second subpart. So the main task over here is to enter a character. Like I'll create a process name, and if the character ends with E, then I'll terminate the process. So what I'm doing over here, I have certain variables and I'm entering a character one by one with the end character being E. So while it's true, then I'm reading all the characters, and if Cn, that means the character is E, then I'm breaking it and I'm incrementing the value of n one by one. Next we have m value will be n minus 1. Then I'm printing the statements, then I'm creating process IDs, and I'm initiating I'm creating a new process using fork. So same process like the previous one. If process ID is 0, then I'm getting the child process ID and I'm reading I'm outputting the characters one by one and I'm reversing the string. Next I'm sleeping for 5 seconds. If the ID is greater than 0, like we did in the previous one. If the process so I'll get the process ID over here, and the process ID is fork. So once again, if the process ID 1 is 0, then this process ID C is being read over here, and palindrome means that the forward digits and the reverse digits should be the same. So if this is taking place, then it's a palindrome, else it's not a palindrome. So I'll simply show you the output over here. So the output will be enter the characters. So E will not be read over here. So as we know that LOL is a palindrome, so I'll end it by E. So now I'll wait. Reverse string is the same as we can see. So the child process has been assigned, the parent process has been assigned, and the process ID for C has been assigned. Now as we saw that if we reverse the string, it is the same, so we get the result as a palindrome. So this was the 8th experiment. Thank you for watching this video.